Okay, so welcome in. Thank you very much for coming. My name is Dr. David A. Wheeler. I'm here to talk about open source software and security. I will give a presentation. I will try to answer questions, and afterwards, I realize we have limited time, so I'll be delighted to talk with people afterwards as well. Here's the outline of my talk. I will start with just some brief introductions. I will go through those in a hurry, since I presume that we already know what open source software is and so on. But I'm going to focus primarily here on security, a little bit on some extreme claims, and then focus in on two areas: unintentional vulnerabilities and intentional vulnerabilities, and talk a little bit about those. And I'll also close this talk briefly with something, a project called Open Proofs, which is actually using open source software in a somewhat different sense. Most of my talk and the other talks here are about using open source software to use or develop software for which it's generally understood what it's supposed to do, whereas this one is about, this last part I'm going to talk about how to use open source software to mature research, particularly in the area of security. But most of my talk will be on security properties in general, not about research. Hopefully all of you by now know what open source software is. Quick definition, just make sure all on the same page. It's software where you can run the program for any purpose, study, modify, and redistribute copies of the software. And antonyms include proprietary software. Now, why would organizations use open source software? Actually, Dr. Dirk Riley gave a whole lot more information, but here are at least some of the reasons here. And frankly, I think one of the reasons that people mention often is that last one, sort of the controlling your own destiny. So they have a lot of potential. Now, I actually had an interesting conversation just a moment ago with Dr. Dirk Riley. I do want to emphasize that open source software is commercial software. He and I talked briefly. It's sometimes a challenge because we don't necessarily have the right words to write things. But he mentioned a number of reasons why it's, in the previous talk, why it's commercial. It's interesting to note on the third bullet, the Linux kernel, back in 2004, it was noted of the last 37,000 changes that had occurred at that time with it. I'm sorry, last 38,000, 37,000 of them were done by people paid to develop that software. So there are certainly volunteers, and volunteers are welcome, but it's not solely volunteers anymore, and hasn't been for a long time. Although perhaps it's not so important here, I should make a note that in the United States, excuse me, let me try again. In the United States, by law and regulation, open source software is commercial software, and I've actually pointed out various laws and regulations and so on. I point this out because many governments and many businesses already have rules about how to handle commercial software. And if you tell them, oh, here's some software, it's not commercial, it's not government, you didn't write it, a lot of businesses have the response, oh, I don't know what to do with it. I have policies for this kind, I have policies for that kind. What do I do with it? In most cases, the simple answer is you already have policies for commercial software. If you're going to use software, here it is. And just follow the rules you already have. And typically that works much better than trying to create whole new policies and regulations to deal with open source software. Now, so that's a quick introduction here. Now let me focus here a little bit on what I'll call the typical open source software development model. This is highly abstracted, but I think it's useful, and it points out some important issues that are very important to understanding security in open source software, which is the point of my talk. I could actually spend my entire time on this slide, believe it or not, but I won't. Instead, I want to start by pointing out the center box here, which says trusted repository. Typically in open source software is developed as a result of a project, an open source software project, and that project has some sort of location on the web where the official version of it is kept, where bug reports are kept, discussions about the software are kept, updated versions are kept, and so on, and that's the trusted repository. Users can go to it directly or get it via distributors. Those who can make commitments, changes to the software in the trusted repository are trusted developers. There may be other developers, but they need to go through the trusted developers in order to make those changes in the official version of software. Well, the biggest radical change in open source software development is that users can eventually become developers if they choose. And this is important to understand a lot of the security issues because just changing software in some random location does not matter to other users. What matters is getting into the supply chain, and I'll talk about that more in a moment. There's an old proverb I learned about recently: a hand by itself cannot clap. Basically, working together can accomplish much more, and that's really the whole point of open source software development. All right, now I'm going to move on with that background. I'm going to move on to the primary purpose of my talk here, which is to talk about security and its relationship to open source software. I've heard some extreme claims. I've heard the claim that FLOSS, or open source software, is always more secure without any possible exception. And of course, you'll hear the opposite, typically by someone trying to sell you proprietary software, that proprietary software is always more secure. And of course, the reality is much messier than that, but is also more realistic, which is neither FLOSS nor proprietary is always better. That said, FLOSS does have a significant potential advantage called the open design principle. And it certainly is true that there are some specific FLOSS programs that are much more secure than their competitors. And so if you're looking at FLOSS from the viewpoint of security, if you're acquiring it, then you need to examine your options. If you are developing FLOSS, you need to determine, well, how do I develop secure software, and then make the choices to make that happen. And with that, now I'm going to move in much more detail about those. First, some brief statistics. I actually have a very large, I think it's something like a 140-page document now of statistics related to open source software. I will not bore you with all of them. I will just simply note that there are a vast number of statistics that show that at least specific FLOSS programs, by specific measures, are better than at least their competitors in their particular market niches. I won't go through this in detail. I certainly could, but I will just point out that there's a lot of statistics like this, and there's many, many more. Security turns out to be very difficult to measure for a variety of reasons, and the few measures that exist tend to be for very, very specific pieces of software. The only study that I know of that does a much broader swathe across a large variety of software isn't really a security measure, but a reliability measure, and that's the FUZZ studies, which found that in general, FLOSS applications tended to be much more reliable than their competing proprietary software. And in this particular study was probably the closest there is to a controlled scientific study. Although, as I said before, it's about reliability, not security, which is not exactly the same thing. But again, you can actually find a lot of studies that certainly indicate that a wide variety of FLOSS programs are more reliable as well as being more secure than their competing proprietary software. Doesn't always happen, it often happens. Another interesting data point that's not a quantitative measure, but I think is helpful to at least understand that perhaps other people believe this, is that the United States Department of Defense commissioned a study back in 2003 to examine security, among other things, in open source software from an organization called MITRE, which is a think tank. It's an organization whose job is to study these sorts of things. They did an intellectual, a what-if game. I don't know how else to describe this. They hypothesized a possible situation and then examined what might happen. They hypothesized that perhaps what would happen if the Department of Defense banned all use of open source software. And what they found was that, in fact, this would be incredibly disastrous for the Department of Defense. In fact, the DoD, the U.S. Department of Defense, uses open source software to quite a great extent, and had a variety of reasons, including, in fact, a number of reasons specific to security for using it. Now, I mentioned earlier, is FLOSS always more secure? And of course, the word always often follows the word no. It's often followed with the word no. There are two open source software programs in particular I should point out to as bad cases. Many, many years ago, a program called SendMail was used for transferring mail, and a very old version of the Bind program, which is used as part of Internet